You have to identify whether the number is prime or not. So guys, what is the prime number? Which is divisible by number n itself?
Yeah.
So is 5 prime or not? Because it
Yes.
is divisible by 1 and 5. And what about 7?
Yeah, prime.
What about 9?
Not prime.
It's not. It's divisible by 1. Is it divisible by 2?
3.
3? Yes. By 4? By
No.
5? No. By 6? Not by 7? Not by 8? Okay. But with 9, right? Is 6 prime number? No. So how you will identify how many divisor does a number have? Number of
Factors.
so how you will identify how many numbers are divisible? In which range you're gonna check?
The number, I mean,
by
from 1 to n by 2. Yeah.
n by 2. Okay. Let me see. Okay. Okay. N by 2. Correct. What about 2? If you will half, it will be 1. You're checking in the range from 1 to 1. How many divisor you're gonna find? Only 1. I get it. What I'm saying is you're checking for value 2. Whether 2 is prime or not. So what you did n by 2, right? From 1 to n by 2, which is nothing but 2 by 2 will give you 1. So this is your range. In this range, if you will check, can I say that you will only find one divisor and it will defy your definition of prime number? So what you can do, you can handle this case separately. If n value is equal to 2, then simply return true. You can create one function. Do you know how to write on the create a function, right? So your function will return true. If this condition is false, then you can write your logic of the 1 to n by 2. Is this part clear? Now, let's say how you will check whether that particular number is divisible by n or not. See, for 6, you have to check whether all these values are divisible by 6 or not. Sorry, 6 is divisible by these values or not, correct? So how you gonna check that? You will go with the remainder 0. If remainder is 0, so what equation I should write in order to check for the remainder? Modulo with 2. So 2 is in static value, right? Why you have to always mod with 2?
Mod with I.
You can mod with I. does it generalize the equation? See, when your loop will iterate, initially I value will be 1. If you're not able to get n by 2, simply go with n. It's fine. You have to iterate from 1 to n. You will check all the values, whether these values are divisible by, sorry, n is divisible by these values or not. Let's say n is 6. So initially I value will be 1. 6 mod 1, will it be equal to 0 or not? Yes?
Yes.
0.
Correct. What's the next value of I? 2.
2.
6 mod 2, is it equal to
0.
0?
0.
6 mod 3.
0.
What about 6 mod 4?
2.
It will be equal to what?
2.
2. Is it clear that when you will divide, you will get the remainder as 2? Now you're able to identify whenever my control is going inside this if condition, definitely it's a divisor. Then what to do? Count, we can go for that. So for prime number, how many divisors are possible?
2.
2 divisors are possible, number in itself. So can I say that
Yes.
for every number, I should try to count how many divisors are possible? I should count, right? So in order to count, I
Yes.
should have one variable to store that particular result.
Yes. Count is equal to 0.
Correct. So I can declare a count equal to 0. And whenever the control is going inside the if condition, what should I do?
Count plus plus. If count is
We can increment the count. Now we incremented the count. After that, what should I do? Why break?
yeah, break we have to.
We have to check the count is equal to 2 or not.
Correct. That you can do. But where you will put that if condition? And
Outside. After for loop.
Outer for loop.
correct. So
Yeah.
here we can finally check if count is greater than 2. Yeah, so we are returning true or false as of now from the method. So I can directly return false. Make sense? Because it's not a prime number, right?
Yes.
And in the else part, we can return true. Now logically think, does this if else is required? Is there any way I can simplify this as well? So what we'll do, we will write down the code. Meanwhile, you can think, can we optimize this or not? Again, the input format is pretty simple. You have to read the single integer, which is nothing but value of, okay, we are here, right? N is 10 to the power 9. It's fine. Okay. Yeah, we will create the scanner and is this part clear so far? We are creating an object of scanner, we are reading the single value in, and this is the loop, right? You have to check for all the values, whether these values divides n or not. So what is an if condition? We decided we will write it down. N mod I should be equal to 0. If it's equal to 0, what should I do? Count plus plus.
1 plus plus.
So see, when we are solving the problem statement, whenever there is a need of a variable, then we are going and declaring it. What people generally have a habit, let's say solve the problem statement, and if interview will give you the problem statement, you will create n, you will create count, you will create everything at that moment. So sometimes it seems like you have by-hearted that particular code and you're just reproducing it. I'm not saying you can't do it for the easy problem statement, but when the problem statement is complex, it's not feasible that you can remember all the variables name in the beginning. So what should I do? If count is greater than 2, do you have to return true or false, or do you have to print true or false?
Print.
We have to print, right? We're in the main
Yes.
method and the problem statement wants us to. Okay, I think return is wrong. It should be print. I'll rectify it. Let me note it down. Output statement needs to be changed. Cool. So if count is greater than 2, we should print false. See, even though I can type false, but I prefer copy pasting because sometimes what will happen, this F will be capital in few of the problem statement. If that is the case, you're trying to pin the small letter and it will give you wrong answer and you won't be able to identify what's happening. Anyone has any doubt in this particular problem statement or any piece of code you're not able to understand, especially this modulo part? Is this clear? Anyone? Is it clear to you, the modulo part? Cool.
Yeah.
Sorry? Okay, so the way we were solving the problem, okay, let me go back. So as of now, this entire logic is in the main method. Let's say I move this logic into a function, let's call check prime. Cool, and I'll pass the value n over here. And let me have this method. What will be the return type of this method? Boolean, right?
Boolean.
You're clear with that. Public static Boolean. Check prime.
Intent.
And you have to pass the integer n. Okay, the statement does not belong here. Now, instead of this, can you directly write it in this way? Return count less than, sorry, return count equal to 2. So if this expression is true, what it will be equal to?
True.
If let's say count value is 2, 2 equal to 2, it will be equal to what?
Boolean true.
True, right? See, these are the expression. These expression either evaluate true or either it evaluate false. Is this part clear? So 2 equal to 2, true. So if n is prime, when you will run your logic, the value of count will be equal to 2. correct? 2 equal to 2 will return true. Let's say value is greater than 2. If value is greater than 2, then this count equal to 2 will be false. So this expression is false and you will be returning false from this method. So you don't need this if else. Join the meet, like I'm not able to see the chat. Join the meet, turn on the camera, I'm not able to view the chat. Okay. Chats. Yeah, it's fine. Because what you want me to repeat for the prime number? Let me run the code. You got it? Okay. Cannot find symbol N. Okay, okay. Let's change it over here. Works? Okay. Now, let's try to discuss this particular problem statement. I'll say take 5 minutes, think about the problem statement, and then we will have the discussion. As of now, do not worry about the test cases. We will discuss that. We're not even trying to solve. Pen and paper. Guys, if you have any doubts, please ask. Any query, please put it in the chat. I'll try to answer that. So you can take in the sample input. It will give you the more clarity. For example, number is 6. The divisors are 1, 2, and 3. If you'll add, it's equal to 6. If it's 8, the divisors are
That is not number.
Chetan.
okay. I'll try to explain. Trust me, guys, you have to try. Even you're blank, at least you would be able to write the scanner class, you will be able to read the input, something you would be able to extract from the question, right? And I'm not saying that in the first time you will be able to understand. For me, when I solved the first problem in the code chef, it took 1 hour to understand the problem statement. Just to understand what problem statement is saying. So it's fine if it's take time. But you have to try. Okay. So let's talk about perfect number. If let's say value is 8, can you tell me the divisor of 8?
1, 2, 4,
1, 2, 4, 8. It says that exclude the number itself. So I can exclude 8.
and
These are the
some.
remaining values. Divisor 1, 2, and 4. If you will add, it will be equal to what?
8.
4
It
plus
should be
2
8,
plus
but
1,
it will
7,
be
right?
7. Yeah, it
7.
will be 7.
Is 7 equal to 8?
No,
No, right?
that's
So it's not a perfect number. Let's say
yes.
value is 6. What are the divisor of 6?
1, 2, 3.
1, 2, 3, 6. Exclude the number. You will add, it will be equal to
6.
6. Okay. It will be equal to 6. Is 6 equal to 6? Yes. Answer is yes. Okay. Now, if this is clear to you, try to think what you have to do in order to solve this particular problem statement. Correct. That's it. If you don't know that, you can write down the logic. Do you have a laptop right now? You can write down independent paper. It's fine. So what is the first step? Can I say that reading the scanner, creating the object of scanner, reading the value of n? Now, if you look into the trace which we did, can I say that the first step which I did was to find all the divisor? How to find all the divisor?
Prime
Same
model.
logic as the prime number. Can I use it over here to find the divisor?
That modulo. Yes.
Do you agree with me that I can use the logic of prime number?
Yes.
Okay. In the prime number logic, let me copy paste the code. This was the main logic. And this prime number logic, can I say that whenever it is going inside the if condition, we are finding one divisor? Do you agree with this assessment or not? Whenever it is going inside if condition, we are finding one divisor. Now, what is the value of the divisor?
I, right.
Everyone agree with the that the divisor value is I?
Yes.
Yeah.
Sure. You agree with that the divisor value is I?
Yes.
Yes.
Yeah.
Now you found I to be divisor. Now tell me, do you need all the divisor or you need the
Whose remainder is equal to 0 that
except n? So can I say
Yes.
that this equal to will gone,
Yeah.
right? I don't want to check n as in divisor, right? But I need to check all the other divisor. Now, once you got the divisor, what should you do?
we'll add that division.
Sorry, I didn't get you.
We'll
We'll
add
add
each of
divisor.
them.
Yeah, we are not considering it. Yeah, you can go for n by 2. See, n by 2 is not the optimized form. There are many ways to, what you can say. There isn't something called time complexity. When you have a study of the time complexity, O of n or O of n by 2 are considered same in terms of time complexity. Yeah, it will be half of it. I get it. It will be half of it. But so whenever we discuss the optimization, we bring the problem statement from, let's say, O of n square to O of n, right? We reduce them drastically. We're reducing just to have it will give you better result at the runtime. Definitely your algorithm will run faster, but I won't consider it to be much optimized solution. Okay. So we'll discuss how to find all the prime numbers in an optimized way. There is an optimized algorithm for the same. Okay. So let's get back to the problem statement. Whenever it's going inside if condition, we are saying that we find the divisor. What should I do if I find the divisor?
You should add each of them.
Add each of them. If I need to add each of them, shall I declare a variable over here?
Yeah, we need one variable. Some.
And instead of count plus plus, what statement I should write?
Sum is equal to
sum plus
I.
I, correct. And instead of comparing with this statement, I should, what?
Is equal to n.
Print.
Sum is equal to n.
Sum equal
Yeah.
to n. If it's equal to n, then it's a perfect number or not. So if you notice, in order to solve this particular problem statement, we reuse the logic of prime, correct? We already studied how to add all the numbers from 1 to n, first and natural numbers. But here, instead of adding all the numbers, we are adding based on certain condition. Same thing we did it for the, when we are adding all the odd numbers between 1 to n. We did this when we were finding all the multiples of 4, right? Similar kind of if condition we have written. So the point is, we expect that you should solve these kind of problem statement on your own once you have the knowledge, right? So what I'm trying to present is even the new problem statement is made up of small concept which you have already studied. So that's what we're gonna do in this entire course. We're gonna learn these concepts so that a new problem statement is given it to you. At least you should be able to, we expect that you should solve 100%, but even if it's not, you should be able to 50 to 70%, you should be able to solve, right? Cool. If you have bought your laptop, I'll suggest that you can solve the problem statement right away. If not, write down in pen and paper. I'll check. And those who are attending online, please write down and give it me in the chat. Someone has shared the answer to me. Yes, your logic seems correct to me. It's exactly the same thing which we discussed. And written yes and no, that's also perfect. Okay. So Vinod, in this case, you will print yes and no. I hope I'm clear with that.
Yes, sir.
Yeah, that's great. Others, please write down the logic. If you have the laptop, you can verify on your own. If you're done with that, you can work on count factors. Is there anyone who has written down the logic for this? 3 folks? Okay. It's 8:47. We will check the submission of everyone at 8:52. Okay. Let me write it down.
Hello. Hello.
Let's check the repeating responses at the end of the class. Cool guys, shall we discuss further? Okay, you're
Yeah.
getting the wrong answer. Yeah, I get it. We missed one part to discuss. Let me take that up as well. So we figure it out. There are two blockage while we are understanding this particular problem statement. Let me explain that up. Let's say when you're trying to find the perfect number, value of n, let's consider it to be 6. Cool. You're trying to find all the divisor of 6. So divisors of 6 are 1, 2, 3, and 6. Do you agree with me? Now, if you add all these number, can I say that every time sum will be greater than a number? Because a number itself is present over the site. Do you agree with
Yes.
that? Take any number, even let's say it's prime, 5. It will have two divisor, 1 and 5. If you'll add, you will always get the sum greater than 5. So there is no point of creating the question. So do you get it that I should exclude this value? And it's mentioned in the problem statement that all the divisor except number itself. So can I say that my loop should go from 1 to n minus 1? Do you agree with me or not? Those who have made this mistake, I less than or equal to, do you agree with me that you should go till n minus 1? Yes or no? Sure. Now, let's write down the for loop. Int I equal to 1, I less than n. When you write less than n, definitely your loop will stop one step
N
before
minus 1.
n, right? N minus 1. It will stop at n minus 1. Now, we discuss this condition. If n mod I, if it's equal to 0 or not. So what does this condition signify?
Is it divisible by number or not? By I or not?
Correct. So in this case, can I say that I will be having value from 1 to 5? It will be having a value 1, 2, 3, 4, and 5. Do you agree with me? If n is equal to 6, I will be having a value 1, 2, 3, 4, and 5. Correct? What you're
Yes.
trying to do, n value 6. You're trying to do 6 mod 1. 6 mod 1, is it equal to 0?
Yes.
You can do the elementary like this. 6 is here, 1 is here. We divide it. 6 times 6, we got value as 0. So correct. What about 6 mod 2?
0.
Same goes for 6 mod 3. What about 6 mod 4? What value it will be equal to?
2.
It will be equal to 2. Elementary, again, we can go 6 is here, 4 is here, and 1 time 4. We're left with the remainder 2, right? So can I say that for 4, this if condition is false?
Yes.
And what about 6 mod 5?
1.
1. So for 4 and 5, can I say that if condition is false? But for 1, 2, and 3, the if condition is true. Do you agree with me? If condition is true, can I say that 1, 2, 3 are the divisor of 6 and I should add them? And this is the logic of adding which we discussed, sum equal to sum plus I. Correct? And we can declare the sum variable. Is there anyone who is not able to understand this particular logic? Now also let me know. Is it clear now? Sure, it's clear. If it's clear, we can go to the next problem. Shall we?
Yeah, it's clear, but it is not getting correct answer. Same program I written.
Yeah, that's what I'm saying. It will give the right answer. Just give me a minute.
Okay.
I'll tell you what is being missing from the code. We'll write it down. Okay. So let's declare and scanner, right? Scanner sc equal to new scanner of system.in. Correct? Int n equal to sc dot next int. Now what to do next?
Sum.
You
For
have to
loop.
loop the loop. Loop should go from
I is equal
1
to
to
less than
less
n.
than n I plus plus. Correct? If condition, if it's equal to 0, then what should
0.
I do? Oh,
Sum.
yeah. Sum equal to sum plus I. So we should also declare the sum variable and sum equal to 0, sum equal to sum plus I. Once this is done, what should we do? We can check
If
if
sum
equal to n,
n.
then what should I do?
Print yes.
Print yes. Can I print yes in smaller case?
Capital.
No, right? Yes should be smaller and no, sorry, both should be capital.
Capital.
Okay. Else. Now, let's read the problem statement carefully. What does it says? You are given the number of test cases. For each test cases, you will receive an integer n as an input, and your task is to determine whether n is a perfect number or not. So for what it is trying to say, I won't give you a single integer n. I'll give you n t times. Let's say t value is 3. So you have to execute this logic 3 times and tell me whether all these 3 numbers are perfect number or not. So should I copy paste this code for 3 times? So I can put it in the loop. I want to execute this logic not for one time. I want to execute this logic for, let's say, 2 times or 3 times. So let's call it as t equal to 1, t less than or equal to 3, and t plus plus. If I will do something of this sort, can I assume that this logic will execute for 3 times because it is inside this loop which is starting from line number 10? Clear? Now the point is, this 3 value is not fixed. You have to read it from the user, which is nothing but number of test cases, right? So let's read the value from user. How many times you want to check whether the number is perfect number or not? Clear? And we can replace it. So if you look into the sample example, sorry, it should be test case. Value of t is what? 2. See the input one. First line contain an integer t, number of test cases. So t is 2. Then you are given 2 numbers, 8 and 6, for which you have to tell whether it's a perfect number or not. So for 8, answer is no. For 6, the answer is yes. Is this part clear about reading the test cases? Sure, it's clear to everyone?
Yes.
Is it clear? So see, first 2 will be read and stored inside this test case variable. Inside the loop, you will read the first value, which is nothing but, let's say, 8. You will read it, write down the logic, whether you will execute this logic, whether if condition will execute or else condition will execute, doesn't matter. You will print it. Then in the next iteration, you will read another integer, and for that, you will print the desired output. Okay, so this is done. So those who were getting the wrong answer, do you get it why you were getting the wrong answer in the hacker rank? Right?
Yes.
Okay. Ideally, I need to discuss one more problem statement. Do you think it was heavy today so we can stop? You want to have some question on this? You want to understand the test case part? Okay. Yeah. See, in the problem statement, is it mentioned that your code won't be tested for one time, your code will be tested for t times? You're given the number of test cases as t. For each test case, you will receive an integer. Okay. For example, problem statement says something of this sort. First, it will give you how many times I want you to reply the value is prime or not. For example, I given the value is 4. Is 5 prime or not? Is 8 prime or not? Is 7 prime or not? Is 10 prime or not? No. So you did the calculation 4 times, right? First, I've given you the test cases. Then I've given you 4 integers. Based on 4 integers, you have done the processing and given me the output. First input, first output, second input, second output, right? You did it in the same way. The same logic we have written it over here. First, we have given the test cases. How many times I have to identify whether the number is perfect number or not. And then I'm giving each value to check whether it's a perfect number or not. Is this clear? Guys, if you have any doubts, you can ask. We are ending the session today early. We wanted to discuss this particular problem statement. You can try. We will discuss that tomorrow. Okay? And guys, if you have any doubts, please wait. If you have copied the code from someone else, please wait. We can have the discussion, we can understand the problem, and we can solve it. Right? Never have a just understand that once you get the job, do you even worry who was sitting next to you or who was your classmate? Are you ever gonna meet very less chances? Even let's say you're a good friend, you will you can connect with each other. But the point is why the opinion of other matters to you. It's your doubt, it should be resolved. That's it. Yeah. Is it audible, Vinod? Yeah.
Yes, sir.
So that should be the priority. There is no so I have a theory. If you asked out, maybe you're fool for some time, but if you don't, then you're the fool for the lifetime. Right? Your doubts are not getting cleared, your time is getting wasted. It's your responsibility. Cool, guys. Anyone has any doubt? If you're attending online, please respond. If you have any doubts, we can discuss, else we can end the session.
Sir, just wanted to know what is the plan. We have this DSA basics challenges, right? So first we are going to finish all of them, and then just
Yeah,
wanted to
of course.
understand what
Then
is
we
the
will move to
plan.
the complex topic. Correct. So
Oh,
we
okay.
are adding the questions daily. As of now, like earlier it was 60. Now it's around 60, 62. And once we have solved 30 to 40 questions, I'll add next set of questions to this contest.
Okay. Then what is the Saturday contest you're talking about? It's different one?
So Saturday contest, yeah, it will be in different one. It will be timed contest. So within 2 hours, you have to solve 3 to 4 problem statement in order to know your progress.
Got it. Okay.
Okay.
All right. Yeah.
Yeah. I have to share the GitHub link. Not able to find yet. Let me try.
What is
Just
the
give.
GitHub link about?
Yeah, it will contain the links, whatever you have discussed so far.
Mm.
The Excel sheet, the notes. So I'm just trying to find it out.
Okay.
Just give me 2 minutes. I'll share that with you. I think this is the one. /Ashok IT. Yeah. So you can go with this link. Guys, if you can note it down, this link will be helpful. It's an Ashok IT DS is the handle name, right? So you have to just github.com/Ashok IT-DSA, and then you can go to DSA basics, right? So whatever we are discussing, let's say link for the problem, the sheet which we have created. So in the sheet, if you will try to visit, you will find I'm adding questions with each topic. Let's say if else is done, what are the questions you have to solve? What are the practice question you have to solve? So as of now, recordings are uploaded in the YouTube. So YouTube link, else I'll attach the Zoom link or the Ashok IT link, whichever is feasible. And yeah, this is the one, Ashok IT hyphen DSA, right? So Imran, first log in into the hacker rank, then click on that particular link. It will work. Right? So if you go to, let's say, if block, whatever the problem statement we have discussed, you can find the details notes of it. Okay, a pseudo code. As of now, do not worry about time and space complexity, but yeah. So this will be helpful if you wanted to revisit the any particular problem statement. Cool, guys? Okay. Guys, anyone please turn on the camera. I need to get that annotation again. Uh, allow. I'm not getting any options now. I can't even find the meeting controls. Cool, guys, you can leave. Admin team will end the meeting from their end. Okay. Thank you, everyone.
Okay, sir. Thank you.
Yeah.